Okay, thank you very much for attending. Normally, E2E Saturday, 10 o'clock, you get only a zombies, and even though zombies need a coffee first. I hope you are all right. I hope you can all speak as well. When you have questions, please tell it, because I would like that will be a discussion. I organized this presentation like in last week. I think it's very interesting topic, and let's see what we can tell about ARM, NVIDIA, Apple, and what impact it has to our industry. Okay. The next slide. Yeah. Okay, for the people on the session which don't know me, I am Sasha Masic. I work for a company called Dataport, and I'm ambassador of E2E. I'm the expert since a few years, full-blown certified architect. And as disclaimer, what I tell you in this session is actually my personal opinion, has nothing with my should not be necessarily opinion of my company or people in my company. It's clearly that's my thoughts on the topic. I have no connection with Apple, NVIDIA, ARM, and any other company in this presentation. Okay, though I have stocks in AMD, which is still not a reason to be biased on the topic. Okay, any questions so far? Okay, I cannot hear you. That means even if you have questions, doesn't matter, I cannot hear you.
They can still ask you questions. Sorry, Sasha, they can still ask you questions, but I'll forward you those questions and they'll appear in your GoToWebinar. Okay,
that's unfortunate because I would like to discuss some topic with them as well on some slides, but still, it's special times. I think we need a special presentation as well. Yeah. Okay, let's start in the morning with Uncle Sasha tell you a fairy tale. Grab a cup of coffee, maybe with shot, and then let's start with the fairy tale. Yeah. As you wait, I see where the problem is. Yeah. The whole history of ARM started in 1990. Actually, Apple has a great idea to build a small device, which will be something special. In 1990, Apple was also not so cool company as is today. Actually, that was company which was about to go bankruptcy and die in a few years. But they tried to make one special device, and for this they want to license technology for Arcore. But problem is that Apple in those times didn't want to pay a royalty fee to concurrence, because Arcore was kind of concurrence, and they decided to come together. And in particular, Arcore gives 12 engineers, Apple gives money, and via LSI, that's company which give up them tools to make processors. And ARM means actually advanced RISC machines. I hope for you that you know no difference between RISC and CISC processors. I will not go into it in this 40 minutes. But if interest is there, I can do for next E2E some CPU architecture track. For me, I am really interested in topic, and it's like I really don't have talent to design chips, but you don't have to be a musician to enjoy music, and it's a topic which I really follow like 30 years or 40 years almost now. What comes out of it is they built Newton, which was not huge success. Despite all great stuff which this brought to the world, Newton was not really huge success, but the design of the CPU was sold was licensed to Texas Instruments, and Texas Instruments sold the chip to Nokia, and that's actually started because this iconic telephone model 6110 from Nokia was actually the start of licensing business of ARM. And you know the mobile phone started. Everybody wanted the mobile phone, and in 1998, it was the time when this internet bubble started, and they decide, oh, we go we will go public, and they started 1998 to be a public company. But funny though is also they started the Acorn stockholders got actually the stocks of ARM, and funny those Acorn doesn't exist anymore, but ARM is still there. And in 2005 is actually a very important year. They don't only change the logo in the meantime. They also started the chip which later came in the iconic device called iPhone, which brought this licensing. The phone market explodes. The ARM licensing goes through like roof, and everybody, and most devices in the world, I will say, have ARM processor on it. I must say what lots of people not consider is that even 2007, before iPhone, the most devices in the world had ARM processor in it, because ARM is also in consumer devices like microwaves and stuff. Every electronic device has mostly ARM processor inside. And 2016 was bought by SoftBank, which was like, oh, is this good or bad? It's the same actually as now with NVIDIA. But 2016, everybody thought SoftBank will be the company which will rule the world. 5 years later, now because the problems of SoftBank, ARM was sold to NVIDIA, and I think 2021 they should finish with this acquisition completely. Okay, let's look at the time. Oh, I'm a bit slow. It's okay. Next slide. Okay. Only for imagination, the growth of ARM is actually, when you look at this, is actually unbelievable. They need like 16 years for 100 billion of chips shipped. And from 2017 to 2020, they sold more than 160 billion chip. That means 60 billion in less than 3 years. And you must imagine they project that 2021 they will ship more than 200 millions. And that's unbelievable growth, which maybe is also the reason why everybody wants to have ARM. Yeah. What they do is actually they're selling IPs. I mean, the ARM doesn't. Okay, I mean everybody should know that ARM don't have any factory. They don't have even any. They sell nothing that are intellectual property. They have triad of. Okay, they have more than triad, but in all these licenses you can put in 3 groups. One is architectural. That means that you get this. From ARM how they call it, Befehlssatz. You don't get really chip design. You get the set of rules, and you get you get specification, and that's it. And you can design your own processor out of it. One of the biggest, there are not a lot of companies which can do that. I will say NVIDIA, Apple, Qualcomm. That's actually almost it. Second license is when you can license CPU or GPU or both, and you can license a lot of parts in between, and you can put your processor together. And you can use few parts of ARM, and you can use few parts of yourself, and then you can build the system of the chip and sell it. And if you are not so good in it, you can even buy optimized design, and you can take this and go to TSMC and then build your chip. And that's also great. That means you don't have to, if you need an ARM chip and want to build it, you don't need to have chip designers for it. How they get money for it depends of license. You have to pay something in front. Mostly is that like architectural license is most expensive, but you pay less for chip you sell or produce, and for down license you pay less for the license, but you pay more for on every chip. The prices per chip they come from 10 cents to euro, kind of. It's also, it's not, there is not a price list. You have to negotiate this all with ARM, and then after few months, years, you will get 6 months. It normally take that you came and then used chip. Sign license 6 months. Okay, next. What you get? Actually, you get CPU design. I show you in three. They have 3 different designs for CPU. They have A series. That's actually what we see in mobile phones, in personal computers, or on in servers. They have M series, which is this what is in this. There are series of microcontrollers, which are in electronic devices, Internet of Things, or industrial facilities. And they have R series, which is for real-time processing. That's actually same design VA, but it's design. The goal is to have something which can do real-time operation. And I don't know how good I am in time, and we can, if I don't know if any question is, I can explain you. I could explain you how it works together, but I'm not sure if it's time. But real-time processor is mostly used for stuff which need real-time processing, like controller on hard disk, networking devices. In automotive, it's a lot of ARMs, R series, big enterprise printers and stuff. That's where the series is. These all designs are actually, the design goal of all these designs are to have low energy and be as simple as possible for the task they do. Even though this A series is, as we see later on Apple Silicon, actually pretty, how to say, pretty fast for how much energy it uses. Any question on it? Okay, I cannot answer it because I cannot hear you, but write everything we can discuss after the session then. Okay. When you buy a CPU and GPU, you still don't have a chip. That means you have to integrate this in your design. Mostly, that's one of example, the system of the chip. And what you see here is actually what you have in most consumer devices, is that you have one fast chip. This is Cortex A72, and you have one small combined with the small cores. That means it's called big little design, and that means for when processor power is needed, they will do the big cores. When the whole system don't need so much power, then they will switch to the small cores. Then you can combine this with I/O devices, with interfaces, with graphic cards. Mali is this what you can get from ARM, but you can also you can exchange everything of this with your own design. As far you are not using complete design for ARM. That means it's very flexible. It's also can fit your needs in any way you need it. You can build a chip which are extremely tailored to your need, and that's actually why ARM is so popular and why it has so big impact in the industry as well. Okay, when it's so important, why they sell it? Yeah? I must say, ARM do with selling with this IP design, they did like 1.6 billion revenue in 2019, which is for selling piece of paper with specification, a lot of money. I think SoftBank never sold it, would never sell it, but they did an $18 billion loss in 2019. They had a few bad bets on VWork, Yuba, Slack on one bet, which is internet over satellite, which actually played from bankruptcy. That means they had few bad decisions in 2019, and has also a rough day, and they have to. That's the most reason why they have to sell it, because they need money. Okay, but why sell it to NVIDIA? Actually, when you look at the market, I wrote few companies. You can put this. You can forward this list. Actually, if something, you can put a lot more company which would have interested on ARM. But problem is the guys you see on the right, Huawei, AMD, Intel, Samsung, Qualcomm, they have no money for it. Our different reasons. Huawei, because they have a stress with the American government. AMD doesn't have money at all. Intel has problem with 10 nanometers process and has also kind of problem with money. Samsung, Qualcomm, they are simply not big enough to afford to buy ARM. Actually, SoftBank goes first to Apple, but Apple business is not selling IPs to other people. I think that's the biggest reason they didn't want it. I think fixed 40 billion is not so much for Apple at all. And second thing, actually, Apple will get stressed with governmental agency about monopole and stuff. And I think that's the most reason, because Apple says, no, sorry, I have this architectural license. NVIDIA will not, if whoever bought it, they will not change the license. I don't need ARM, and that's the most reason, because Apple didn't. And NVIDIA is actually, I think, the only company in the world which could buy ARM at all, for us, my point of view. Did they should buy it? That's actually what we try to answer in next few slides. But actually, they are normal candidate for it. And best of it is, if some of the part of the right bought ARM, they will bought it through stocks. They will give their stocks for ARM stocks, and that will be not so good for SoftBank, because they need money. And the deal with NVIDIA is like this: they will get like 15 billion in cash, or between 12 and 15 billion in cash. Depends how ARM will do in next 3-4 years, and they will get 25 billion in NVIDIA stocks. And when you imagine what happened, SoftBank bought ARM for like 32 billion, and that means actually they exchange like third of their stocks with NVIDIA stocks, and got 13 billion to pay the bills. That's actually what happened here. Sorry that you cannot do any question. Okay, let's go into motivation. Why NVIDIA bought ARM? Okay, what you can read to everyone to everywhere is that they need their own CPU. I must say, I'm not sure that's really true, because NVIDIA has actually this architectural license for ARM. They use ARM in their automotive products, and they also use it for a Nintendo Switch. That means actually they have CPU design. It's true that NVIDIA tried, because they compete with Intel and AMD, they tried to get x86 license, and in some point of time, NVIDIA and AMD were talking about fusion, but the problem was that the name could not be changed, because AMD has this license for x86, and that means if AMD changed the name, the license is not. And also, nobody can buy AMD and get license on it. But actually, AMD should buy both the company, and then if AMD not exist anymore, then it's licensed for x86 also gone. That's something that you have to know. Yeah. Okay. I don't think that because they had their own CPU, and I don't think really that the reason is for. Okay, money. That will earn a lot of money for it. I think maybe, but in really long run. NVIDIA do like $13 billion in revenue to 2020. Or will do, and ARM has like 1.6 billion, and then you can count. They pay 15 billion in cash to SoftBank. How long it will take? Even if you see the growth, it will take, I will say, 6 to 8 years to get this money back. I think this 15 billion in cash. Okay, the stocks, you can count it like no money, but at the end for stockholders it's this money as well, because they get less of the company through this magic. I mean, I don't think. I think that will be one day, that will be plus. I think anyway, but that will be not fast win. Okay. I'm really interested about the opinion on that. Growth. As we saw on the slide before, growth is very high and getting in faster. But when we see where it can happen, and we see phones, I think the growth in phones is limited. It's long term, and I think everybody in the world has already one mobile phone, and we will change the mobile phone, but the pace is not so as was like 2007. I think the phones are definitely not the growing field. Internet of Things, yeah, I think that will have a very high growth in few next years, but it's also long-term investment. That will not happen next year, not in 2 years, and not in 3 years. That to bring a lot of money for ARM. I think it's a business which will continue, and that will bring money, but not so fast, I think. PC notebooks, yeah, I think the ARM design is good enough for daily drivers of PC notebooks, and I think that's also a business that they will gain some market share in the future. But that will, as I said, this is also not fast growing part of the business, and I think it also will not happen next year, despite Apple and despite mine. But I will say they will gain market, but it will not happen next year. But I will say 5 to 10 years, yeah, maybe. Or I'm not there for sure. On server is actually, on server they have a high potential, and that's actually, I think, one of the reasons why they bought it is also that the server business on ARM will come. And ARM processors are now actually, when you look at the threads, ProThread and Watt, faster actually than AMD and Intel and kind of processors. Problem on server is definitely you need ecosystem, and that's actually what problem is for AMD or some other company than Intel to came into this market is because Intel has a perfect ecosystem. And when you buy Intel server, you have like, you know, it works out of box. You have all the tools already, and you don't have to do much to integrate new server in your environment. When you buy AMD, even if it's same technology, you will have more hassle than with Intel. And when you buy ARM, then you have even more hassle. And okay, that will change with the time. But the problem here is if you want to compete with Intel, you have to build an ecosystem, and that will take a time. And otherwise, NVIDIA is a company which has experience of building ecosystems and is in data center, and they have ecosystem with the professional graphic card. Maybe that will help, but I will say that is definitely long-term investment. I mean, long-term, yeah, that has high potential. Maybe in 10, 14 years, 50% of server market will be ARM. Who knows? There are some risks on this part, but we will keep to this as well. Okay, one of the motivation could be is a synergy. No, the NVIDIA has a great experience of designing even ARM chips, and they have also big experience of building graphic cards, and they can put this card of the intellectual property back to ARM. And ARM knows how to build fast and energy efficient devices. And when you look at for example, when you look at the new versions of processors and CPUs of AMD, that's first time they'll also profit from this, that they have both and they can help each other in specific problems. But AMD took that long time because they have no money. And I think for NVIDIA will be a lot faster process than that. Problem here can be if they put too much on NVIDIA MP. The vendors like Samsung, they use different design for graphic, and even they have a partnership with AMD. That can be a problem for some customers of ARM. Despite all of this, I think that's really good motivation that will help. Definitely. I think that is one of the reasons why they did it. I think for me, the biggest thing is this artificial intelligence. Problem is, on the beginning of artificial intelligence, NVIDIA was like, you want to do this, you have to do NVIDIA. In meantime, actually everybody, when you see up this line, they have their own design. AWS, you can use actually a lot cheaper AWS design for artificial intelligence than NVIDIA's. Google the same. Tesla doesn't use NVIDIA anymore. Facebook has their own chip. Actually, everybody have their own chip. And I think through the ARM, they can sell their Tensor technology actually on the wider base. That means they will put this into the ARM design, and a lot of ARM licenses will buy it because they don't have to develop themselves. And I think that will help, or that might help, to spread this part of technology for NVIDIA. Because on the other markets, they have I will say tough competition. But if they succeed to integrate this in ARM, I think that will be a wider spread that they can achieve without ARM, or far wider spread. Okay, one of the problems is selling IP to competitors. That means if you change license model or you adapt the license model a bit, and then then you try to sell it to your competitors, then you say, oh, no, that's not fair, and then you will get this famous internet shitstorm. But even more important for companies is the lawmakers will look at it, and governments, and if possible, some of the competitors will run away, which you really don't want to have. But you will say, okay, where they can run. Yeah, that's the next slide. Alex, I hope that I have this 8 minutes, which I spent at the beginning.
Yeah. Actually, and you also have a question, Sasha. So if you
okay,
questions.
Okay, when we come back, yeah, ask question. Yeah, good. Alex, I will get question now.
Yeah. No, at the end. Let's do it at the end.
Again?
Let's do it at the end.
Okay. Actually, that is an ecosystem which is also growing. Is the same. Is called the RISC V. I don't know. Actually, it should be also broadly known. That's has few advantages over ARM. It's open source. That means you don't have really you don't have to pay anything to see the code, to see the design. Actually, through RISC V, ARM changed how to say they change also the license model a bit. In old days, you have to pay to see any of design. That means you will not get anything before you pay this upfront license. Today, you can even see a lot of more. Second thing is you can buy relatively cheap license for all cores and to see all designs, which was not possible 5 years ago. And most reason for it is RISC V, because it's more flexible, because you can change design of the CPUs even if you take the license. Cost less. It's not for free. Very important. RISC V is not for free. You have to pay something on. You have to pay something to the RISC V board, but it's far less than that what you pay for ARM. And there are a lot of companies in this world, but from bigger one, Alibaba and Western Digital are big players there. And Alibaba has actually their own design on RISC V on servers actually productive in their environment. That means that's not when you buy ARM that you can do everything you want, because there are alternatives, or at least one alternative is there. And if NVIDIA tied the license of ARM in any way, or make it too expensive or too restrictive, the people will run away with the time, not for one day to another, but on midterm they will run away. That means NVIDIA has very important strategic component, but is not really on the monopole side of it. Okay, conclusion for me is actually, as a long-term investment, that was a really important move for NVIDIA, and actually it was also a great moment of time that nobody else could make it more expensive. For for AI, that will be actually and spread of NVIDIA artificial intelligence technology. That will be a very good fit. And IoT is the growing field, in my opinion. In few years, like 10, we will have like this Internet of Things all around us. I will say we will speak about electrosphere or something. You will be like all around us will be a computer. That's like a vision. And in data centers, I think also that for data center and NVIDIA plans in data center, that's actually a really good strategic idea. But as I said, there are risks, and one of the risks is RISC V, but because some of competitors of NVIDIA would not pay licenses to NVIDIA. And we will see how it develops. I think NVIDIA did a good work to buy this, but it's not a potential monopoly on small devices. That's definitely not. Okay. go to the next subject. I know there are questions, surely. I have, I hope, 10 minutes more. But let's see. For a few days, I think last week, we have this, or potentially we have this iPhone moment. And the question is this iPhone moment? You know, is this M1 from Apple, this disruptive technology? Should I sell my AMD stocks immediately? Should Intel actually stop develop this 10 nanomillimeters process and simply give the money to stakeholders because money they still have because it's end. You know, it's in few years we will all have ARM CPUs on our computing device and everything else will be stopped, like iPhone did for this phone market. Yeah, that's really a question. I mean, if I would have this glass, crystal ball to see in the future, that would be nice. But let's see. I think, okay, to begin with, I will say I'm not so sure that will be such a disruptive technology. Will help ARM gain part of the market on midterms in this personal computing. But let's see what we have here. Okay, we are technical conference, and let's see on the chip. It's actually very interesting at how it looks. I borrowed those slides. This one slide by Anantech, another one I borrowed by Apple itself. The chip is made in 5 nanometers TSMC process, which is actually top of the notch process. Actually, there are no better process in the world now. And as I said before, Intel is still fighting with 10 nanometers process, and their 7 nanometers process is actually on hold for ages. And TSMC has actually the best process in the world. They build in this moment, actually, the only big customer is Apple. And the chip itself is, when you see the package, the RAM is on the package as well. That means that's not only the chip, the package is also on the chip. It means when you order the M1 notebook, you can choose 8 or 16 gigabytes, but that's all on the chip. That means you will get 1 or 2 of those. That's it. When you look at this, and look on my slides back to design of the ARM, actually everything it's there. You have the 8-core GPU. Funny those. This GPU is Apple. You know, Apple bought one GPU company a few years ago. That's whole Apple design. They have 2 kind of cores. They have the fast core, that's Firestorms, that's 4 fast cores, and they have 4 slow cores called efficiency cores, and Firestorms are performance cores. Funny names: Firestorms, iStorms. They have also kind of neural engine for AI tasks that you see. They have single layer cache with single layer chips. That's what you have in your SSDs. But the single layers, that means that one cell pro chunk of data, and you have like a lot of DDR4 low energy DDR4 channels around the chip. Very nice. We said we can talk about design in the chat. I think I don't have time to go deeper into it. I show you only one slide here. It's actually great. One of the difference between or in all time between RISC and CISC design was that in all time the CISC design will fetch instructions and the data in the same time on the same with the same engine. That's not true anymore. That also is not true that RISC processors are not CISC, that CISC processors are RISC processors. That's the big difference. Actually, all this technology which started with RISC, you will find in CISC processors as well. Funny here is that they have a very huge reorder by to see 630 reorder. Actually, what modern processors do is they fetch a huge chunk of code. They not fetch only this what they need, they huge chunk of code and try to find out on every how to say branch to find out where it will go. They try to predict where the code will go, and that's the reason why they fetch a lot of data, a lot of instructions. And okay, it's also they have extra engine for instruction, and they have extra engine for data. One of the funny things is they have 2LD. That's for load, and they have 2 for store. But one of the load devices for code can also store. Why is that? Normally, you will store like in less than 10% time, and another round you will load like 90% of the time, that or more than 90% of the time, and that's the reason why this design is like that. We can talk about this also because I see I'm short on time, but let's go faster. We can design this after the show. And pro and contra. Okay, I'd say it's not much contra to say about this device. When you look at this, okay, I didn't have it already. I will have it surely in one point of time. But when you look, it's nobody says nothing bad about this. It's worked like up to 3 days on one charge. Looks nice, like every Apple design, has good performance for good price. Benchmarks are great. But when you look at the benchmarks, what you see is actually that works like a charm when you have native application. The emulation is good enough. It's you don't notice that it's not native. But here's the question: how many of existing developers for Mac or for iOS they will succeed to bring them to change the code for Apple for M1? And if they do this in same way when they did transition to Intel, that will be surely success. I cannot imagine that will be not success. Okay, but question is, okay, if it will be a success, why will not have a huge impact on the world and everything? And that I think is the reason is ecosystem. Apple has an ecosystem. That means they have their own operation system. They have also, I heard, very popular mobile phone operation system, and they can fit this to work like a charm on their design. Problem I see here is Apple will not give this design to anybody else and will not license this design to anybody. And second thing is they will not license macOS or iOS to anybody else. That means in Apple ecosystem, that will work like a charm, but the reason for it is because Apple controls ecosystem as such. Qualcomm, NVidia, Samsung, that's the guys who can build kind of ecosystem on their own or can build such a processor. They don't have ecosystem. They have to buy themselves into the other ecosystem, which could be Chrome OS, Android, or Windows, and they try it all the time. That is not, you will have one of, now and then ARM design to run Chrome OS, or you have design on Windows, but still you don't have really successful devices. And the question is, if they have to have a broad spread like this iPhone and everything, some of ecosystem providers like Google or Microsoft have to do better job to integrate into the ARM platform. And that's what I'm not seeing short term. Maybe in middle term, especially if Apple has bigger success with M1 than with Intel design that can make shifts, but it's not something which happened from one day to another. That means for Apple that will work perfectly, but for others, I'm not sure, because it's not problem of Qualcomm, NVIDIA, and Samsung to build a device or chip. The problem is that this fitting between building an ecosystem is something that somebody else has to do, because they are not big enough to do that. Okay, that's all, folks. Thank you very much.